Hi, your question was about arctan and the tangent. Well, what that means, what is the arctan, and how do you take the derivative of that and make it work out? So I could just tell you what the derivative is, but that's not really useful and it's not an effective teaching practice. So I'm going to briefly tell you in this video about what arctan is, what it means. It's not really that complicated. Taking the derivative is complicated, and I'm going to direct you to a different video for that. So I've got two examples of functions here. The tangent of x equals 1, and I've got the square root of x equals 225. I guess function is the wrong word. I've got equations here. And I'm going to use both of these to kind of illustrate what arctan is. So if we were going to try and solve for x, we know that the tangent of something equals 1, or we know that the square root of something equals 225. If I wanted to solve this equation over here on the right, I would need to undo the square root. Now, that's not a mathematical term. What I need to do is I need to take the inverse. I need to take the opposite, the inverse operation. And the opposite or the inverse operation of the square root is squared. Because if you take a square root and then you square it again, you get back to the original number. If you take the square root of 9 and then you square it again, you get back to 9. And so the inverse operation, the opposite of square root, is squared. So if I put in here, I'm going to have to redo some other stuff here in a minute, but if I take the square root of x squared, I'm going to be left with just x. So I've solved for x. And I have to do the same thing to both sides. I have to keep that equation balanced. So I'm going to take 225 squared. And that's how I'd solve for x. I'm going to use a similar method back here. I'm going to delete a little bit, leave me some room. So I'm going to take the inverse operation, and the inverse of tangent is simply called tangent inverse, which is uncreative. But that's the tangent inverse of both sides of that equation. So you're at the inverse tangent of the tangent of x, and the inverse, applying that inverse to that function, or to that operation, is just going to eliminate it. Just like here, when I square root and then square it, I'm going to be left with just x. Whenever I do the one side of the equal sign, I have to do the other to keep the balance for those equations. So I'm going to take the inverse tangent of 1 over here and clean that up a little bit. There we go. Okay, so I've got my my two examples here. If I follow this down, again, the square root of x quantity squared is going to leave me with just x. So I'm left with x on the left side of that equation, and 225 squared is 50,000. I'm looking at my calculator, believe it or not. I don't know this one off the top of my head. 225 squared is 50,625. So if you take this number and take the square root of it, you will get 225. That's what I've done. That's what I've solved by using that inverse operation. Back here with our original problem, the inverse tangent of the tangent leaves me with just x. Maybe. There we go. Now the inverse tangent of 1, if you plug it into a calculator, you're going to get a decimal, 0.78, something, 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 something. I think it has in the problem that you submitted, the problem you asked about, it says in radians. So we don't want it in decimal form. So I've got a graph here of the tangent function. I just typed in tangent of x. And if I zoom in, I want to know when it equals 1. So I want to know at this point right here. There it is. So it equals 1 at pi over 4. That's what it works out to be in radians. So that's the solution then. When x is pi over 4, and I take the tangent of pi over 4, I'm going to get 1 as the result. So the answer for this is going to be x equals pi, typing math takes way longer than writing math, over 4. There it is. So that's what the inverse tangent does. Now, you weren't asking specifically about the inverse tangent, you were asking about the arctangent. It happens to be the exact same thing. This would be the same as saying arc. It's just another way of writing the exact same thing. Arctan of x of tangent of x equals the arctan of 1. So they're interchangeable. I don't know exactly why. However, I will say that writing it in this way, if you were going to take the derivative, it'd be very tempting to just bring that -1 down and deal with it as kind of a U substitution, or deal with it as a chain rule. It doesn't quite work that way. It's a little different than a chain rule, because it's not exponent -1. I don't know, it gets weird. And so I think that's the reason they have a new name for it, and they call it arctan. So arctangent, arcsine, arccosine basically means the inverse operation, the opposite of tangent. To undo the tangent operation, we take the inverse tangent, we take the arctan. So that's what the arctan is. That's how it functions. And then I'm going to direct you to another video that I'll link in this email that'll show the whole process. If you just want to skip to the end and look at the final answer, fine. But it'll at least show you how they found, or how the derivative is calculated of the arctangent. Okay. Hopefully this helps in that explanation. Hopefully the next video helps in leading you towards the